Okay, I guess so. Hey, thank you. And what was I going to say? Yes, the laptop survived. And so a while back, I was working with a client, right? So the client had this idea. They want to build like an AI code reviewer. And he was going to make lots of money selling it to all the developers like ourselves. And so what we did was we built it with Amazon Bedrock and using a lot of serverless technologies. So as soon as you create your PR, you're going to get a nice little summary. We're going to analyze your code changes. If you find any problems, and we're going to say, oh, look, you've got a little, I think this one is a security vulnerability thing where if you pass on untrusted YAML, it could be unsafe. And so we're going to give you some suggestion on how to fix it. So with GitHub, you can also just click a button to commit the change into your PR and fix the problem right there. So you got all your PR automatically being reviewed. If you go to the website called evalua.io, you can also see a history of all the PRs that we've scanned for you and some kind of summary around the kind of problems we've identified based on severity, whether it's critical, high, medium, low, and so on. And you can also manage your team. So if you want to say, okay, I want to have a bunch of my developers all access the same account and see the histories and see the problems in the PRs and repos, you can do that as well. You can invite other people into your organization account. So you can see what repos you have connected and add new repos to the system and so on. And so that's the high level of what we built. And today I want to talk about our architecture, how we did it, and why we chose serverless and why we chose Bedrock as well. And importantly, mostly the things that we've learned about some of the practical limitations of what happens when you start building with AI, and also especially when you want to build a business by building stuff using AI technologies. So quick introduction of myself. My name is Yan. I've been doing stuff on AWS since 2010. And I've also been part of the AWS Heroes community since 2018. I think John mentioned to me earlier that why you're here today, not in Seattle, or the heroes are in Seattle, but I'm too chicken to, no, I'm too smart to tempt fate with the US customs. Damn it, now it's going to record it. You're going to find a YouTube and say, you're not going to come in, they're going to come in again next time. But anyway, so long time AWS user, since 2016 I've been focused around serverless. And nowadays I work some of my time working with Lumigo, which is probably still the best observability platform, especially if you do a lot of stuff with serverless. And the other half of my time I work as an independent consultant. So I help other companies, sometimes help working with founders who's got an idea for an app and basically try to build it for them. And so this is what we did. This client, he's got this idea to build an AI code reviewer, and I basically work as a backend team for him to build all of everything on the backend side of things while he coded the front end. So on the backend side of things, which is the stuff that I actually worked on, you got your GitHub webhook. So whenever someone creates a PR or makes a comment and stuff like that, we get a webhook event from GitHub to our REST API in API Gateway that triggers a Lambda function. At this point, we don't want to do any processing. We just want to store the event, capture that as quickly as we can so that we can respond to GitHub with a 200. And then we want to then use the event bridge to trigger a Lambda function to then analyze your pull request. We're going to use Bedrock to use Claude or other models to scan your code, make sure that, okay, look at your code, identify any problems you have in your code, and then save any results of that scanning or that analysis into DynamoDB. But we also have a fallback to Anthropic so that we can use Claude through Anthropic's API directly as well. I'll talk more about why we have this fallback in a minute. So on the front end, we've got the website, which is a single-page application, and it's talking to our backend, which is an AppSync API. The reason why I use AppSync is because GraphQL just works a lot better when you've got a lot of different pieces of data you want to pull together in a single page that have to display multiple things. So GraphQL works really well for that. And the AppSync API talks to DynamoDB directly with a lot of the JavaScript resolver, but also it's got a couple of Lambda functions as well. For user management and authentication, we use Clerk instead of Cognito, partly because the Clerk has got some really nice utilities out of the box, including things like support for managing organization accounts, inviting people. All of that flow is out of the box, including the UI components you see here. So in terms of getting the product out in the market really quickly, it's just really helpful to have all of that stuff working out of the box. And it's also got built-in integration with GitHub, GitLab, and other Git providers, so that in terms of the authentication piece, it also works very nicely as well. But it does mean that our AppSync API will have to have a custom Lambda authorizer in order to authenticate you and make sure that the token is validated and all of that against the clerk. And whenever a new user is signed up or you create a new organization account, we also have to get a webhook from clerk to capture that, and for and also GitHub as well. And for payments, we're using Stripe, so that we again have to have lots of webhooks to listen to, when you start a subscription, when you add a new user to increase your subscription level, and to know when you've canceled your subscription and so on. But most of that is just the app stuff, and the real AI stuff is all happening inside a single Lambda function. That's where a lot of the AI and smart is happening. So in terms of the challenges we've had, well, for one thing, because we're dealing with customer source code, so those are really sensitive data, right? You want to make sure that everything you're dealing with there, you handle them with care, and none of your prompts, not the input, not the output, are being stored and available elsewhere. We also want to make sure that we are able to handle large PRs, and you often find that most PRs are quite small, but there are some large PRs with lots of files that change, and sometimes in a single file you can have 10,000 lines of change. So we can make sure that we are able to handle that as well. So first question is why do we pick a Bedrock as opposed to using ChatGPT, ChatGPT's API and other things like that? The big reason for us is because security. Again, we are dealing with customers' sensitive data, so we want to make sure that everything is encrypted. Oh, there you go, it's back. It's encrypted at rest as well as on flight, but also, anyone remember this? So DeepSeek came out, and not long after that, they had a database leak. Basically, the ClickHouse database was public, so that all the inputs and outputs of all of the users were available online for anyone who knows where to look. So obviously, we don't want that to happen to us. That would be pretty catastrophic. And with Bedrock, Amazon clearly says in the FAQ that they're not going to take your data, neither your input or the output of your conversation with the Bedrock models. They're not going to use it to train other models. They're not going to sell it to other people to train their models and so on, which again, when you're dealing with sensitive data, that's very, very important to us. Now, because Bedrock is not always going to be available, or maybe some outages. In fact, we had experienced one particular outage just as we were about to go live, which meant we couldn't use Bedrock at all. So that prompted us to think about, okay, what happens if Bedrock is not available, or there's a problem or something? That's why we also have a fallback to use Anthropic as well. But that also means we need to make sure Anthropic has the same privacy guarantees. And luckily for us, it does. I think nowadays, Gemini also has got similar guarantees around the privacy, so that they're not going to take your data to use it to train other models. Oh, there it goes again. Yeah, I'm not sure what's happening. But in terms of, so that's the reason why that's one of the important criteria for choosing what models to work with. And as for serverless, well, obviously I'm a big fan of serverless myself, but also I have to make sure that whatever I'm doing makes sense for the customer and the use case. When we are starting out, we don't expect to have, say, like 1 million users sign up like the first day. So in terms of the pricing, we really like the fact that with Bedrock, it offers both usage-based token count pricing, but also provision throughput pricing as well. So that when we don't have a lot of users, don't have a lot of usage, then we just pay for the tokens we actually use. But when we do have a lot of customers, there's a steady throughput, then we can switch to on a more provision-based pricing, so that we're paying for some amount, so that we can always guarantee a good per token cost when it comes to using Bedrock. And of course, not long after we launched the product, the DeepSeek came out, and then Amazon was pretty quick to add the DeepSeek, especially the R1 model, to Bedrock, and so that you could use DeepSeek models via Bedrock, and you can still get the same usage-based pricing as well. And you can see that compared to Claude, Sonnet, and Haiku, the cost for using DeepSeek on Bedrock is actually quite a bit cheaper compared to Sonnet or the bigger model or Opus. But that is still a lot more compared to if you just use DeepSeek's API directly. Of course, you are just paying for, you get what you pay for, really, right? Because with DeepSeek, they say clearly in the privacy agreement that we are going to take your data and use it to train other models. And also, well, this shit happened. We don't want this to happen to us. I can't stress how important this is to not happen to us. And so, yes, you pay more if you use DeepSeek on Amazon, but you do get better security. You get what you pay for, really. In terms of other things you get with Bedrock, you also have got the built-in guardrails. You have got to manage the RAG with the knowledge base. You got the agents' capabilities, and you got cross-region influence. I'm going to talk about that in a minute. But also built-in evaluation for models and other new things now as well. So there's a lot of things to like about the Bedrock. And of course, now probably the coding model-wise, Claude is probably still up there, but Gemini 2.5 has also been really good as well. So, lessons. Well, what we actually build is pretty simple. All it is really on a high level is got a bunch of webhooks, and when someone creates a PR or makes a change to the PR, we want to analyze your changes, and then we give you feedback on whether or not your code has got lots of problems and how to fix them. But also we use the Lumigo for doing all of the observability stuff on our system, so they can see that when an API came in from the webhook, it gets saved into EventBridge. That requires more because we make a lot of API calls. And this is on a small PR where just like 1 or 2 files. But sometimes we make a lot of API calls because, some PR just have got thousands of files. We have to call GitHub to get every single one of the files' content so we can analyze them. So when you've got so many different things you've got to call, well, sometimes your Lambda function is going to time out. Even if you put it at the maximum timeout duration of 15 minutes, you can still go time out. Partly because, well, the models take quite a long time to respond. If you call Bedrock to, say, analyze a file or some bunch of content text, well, chances are it's going to take 20, 30 seconds to respond. So that adds up when you've got thousands of files you need to analyze. The good thing with Lambda and EventBridge is that EventBridge is an async invocation event source for Lambda function. So you get built-in retry and DLQ support as well. So we did a bit of work to make sure that on the retry, we're not going to analyze things we have already analyzed previously. So that, say, we did like 1,000 files out of the 1,500 you've changed in this PR. The second time, well, you timed out the first time, but then on a retry, we can skip over that first 10,000, the first 1,000 files. So the second time around, you can go through, hopefully we succeed quickly. And in general, we found that for those large PRs, we hit all kinds of limits in terms of the LLM itself, limits around AWS services, but also GitHub limits as well on how many APIs we can call. And so through the whole experience, I can confidently say that the AI part of the problem is only about 10% of the thing we were working on, as someone else also noticed as well. That the other 90% is just about connecting whatever you're doing with AI with the rest of your system to the data sources to make sure that you're working all around all the edge cases, API limits, and things like that. And picking the right model itself is probably a big part of that 10% as well. You see, everyone talks about the reasoning capabilities or the benchmarks measure how well the machines are at the models are at thinking and reasoning. But other things actually maybe just as important, if not more, when it comes to actually building AI applications using LLMs. Things like the context window size, the maximum response token you can have, and the API rate limits and so on. And as for context window, there was a period of time where all the models were announcing, oh, you can now have 1 million tokens, 2 million, and whatever. So everyone was saying that, oh, we don't need RAG anymore. RAG is dead. You can just throw the whole thing into a context window and you'll be fine. So, okay, for us, in this case, can we put all of the content for the single PR, all the different files that's changed, into a single prompt, into a context window instead of having to analyze individual files? And what we found quickly is that, the context window size itself is mostly a lie. I'm going to tell you a bit more why that is. Because all these models that say, so we can take 1 million tokens or what have you, and we can accurately recall precise information from that 1 million token context window. the specific test they use for the benchmark is called the needle in a haystack. So basically, they introduced some small change to like the Harry Potter book, and then they're able to ask the model to pick up that specific change and know, oh, say, that doesn't belong to the original text. You added that. So that's all well and good, but then whenever you ever try to, say, upload a large PDF to any of the models and start chatting with it, very, very quickly you find that it comes back with nonsense, the things that just doesn't make sense based on the content you've uploaded to the model. And so it turns out being able to recall information from a large context window doesn't mean that you can actually make sense of that data that you have in that context window. And this was later on also been called up by, so it was Matt Carey was the guy that actually told me about this problem, this particular benchmark as well, this benchmark called the Fiction Life Bench, that actually checked the model's ability to make sense of the data in the large context window. And what they found was that even as you get up to, say, 32,000 context window size, the ability for the models to make sense of the data pretty much collapsed very, very quickly, except for a small handful of models. So there was the Gemini 2.5, but then there's also GPT-5, it's also pretty good at that, and also now you've got the Grok as well. So there's a few handful of models that are actually able to reason with a reasonably large context window. Everything else, you may have a million token context window, but you can't actually do much with them. So at the time, none of the model had the ability to work with a large context window for us. So it made us, so we made a decision to basically, okay, we have to scan individual files one at a time out of a large PR. And that kind of puts us against several other things we're going to run into in terms of cost, performance, but also API rate limits as well. All of which are important things to look out for as you're picking or evaluating which model is the best for your use case. A lot of time when we talk about model evals, we're talking about just reasoning abilities, how well it's able to perform against your specific use case. You write a lot of different eval statements to check whether or not the model's reasoning capability matches what you're doing, but you also have to think about other things as well in terms of actually building applications using AI. A big one for us was the rate limit that we get. Well, with Claude 3.5 Sonnet, the default throughput you get is only 50 per minute, not per second, per minute. So you can raise that to 1,000 requests per minute if it goes through the approval process support, with AWS support on Bedrock. And Bedrock also has got support for the cross-region inference. Essentially, you can use two different regions so that that basically kind of doubles your throughput you get with Bedrock. But still, that's not a lot. If you're talking about scanning one file at a time, that means a single PR with 50 files that change, that's going to blow away your quota for the next minute. If somebody else makes another PR in that same minute, well, you don't have any throughput left. And so for us, we try to do everything we can to raise our API limits in terms of making those account level limit raise requests, but also enabling cross-region inference to double our throughput. But we also want to make sure that we limit the number of parallel requests we make for each PR, so that if you submit a big PR, we're not going to let you kind of just use up all of our throughput for the next minute or so that other people's PR can't be analyzed anymore. So we limit, basically have some kind of fair use policy there around, okay, how much of our throughput we're going to use on your PR. But also, most importantly, we have fallback to other less powerful models, including that have got higher throughput limits. Things like Claude 3, Haiku, but also Nova and potentially DeepSeek as well, which are much cheaper models as well. So they're also good for cost control. The other big thing we learned is that while LLMs are still quite expensive, and you probably noticed that all the different AI tools are people that build them are always talking about how they have to think about cost, because a single user can easily blow away a lot of your budget. Even tools like Cursor, who was the fastest company to hit 10 million or 100 million ARR. They had to raise their prices not long ago as well, and they cited the reason being, well, some of these newer reasoning models, they are cheaper per token, but they are outputting their thinking as well. So instead of actual tokens, you're actually getting a lot more token usage. from those newer models. And also, when it comes to talking about things like PR and coding, you have maybe like most people are not going to use all that much, so you don't lose too much money on those. But you can have one guy that's going to throw lots of prompts, and suddenly that one person can use up so much of your budget. And that's what they found as well, that you have, for most people, it's fine, but you have some of the edge cases that are order of magnitude more expensive to serve than everybody else. So token cost is going down, and that's great, but then your token use, the count, is actually going up. And plus, not to mention the fact that nowadays, it's not good enough to just do AI stuff. You have to do agents. Everything has to be agents. So instead of one prompt, well, you have agents that's making unpredictable number of moves. Well, how unpredictable? Well, we don't know. That may be what it actually looks like. At some point, we're going to have the microservices Death Stars when it comes to your AI agent networks, especially all these fancy things we've got now in terms of not just tool calling, but you also have MCP to talk to all the world's databases and whatnot. You also have an agent-to-agent protocol so they can discover all the agents in the world and talk to each other, and you have no idea what else is going on in there. But ultimately, the point I'm making here is that, yes, everyone's talking about AI costs coming down, yes, and that's true on the token cost side of things. They're not talking about the fact that, well, we think reasoning models are more expensive because they output those thinking. Those thinking are tokens you are paying for, okay? And the fact that we are building more complex AI systems, especially with newer technology, newer techniques like agents and things like that. So AI cost is still going up when it comes to building what is considered modern competitive AI applications. And that kind of leads to the really painful side of things where it is really difficult to build a financially stable or sustainable business when you're building AI applications, at least for customers. Right? If you're building B2B or internal enterprise use, absolutely, you'll be fine in terms of the cost. That's probably not your number one concern, but when you're doing B2C stuff, that is really, really hard. And I've got suspicion that even companies like Cursor and all these big AI companies, they're all losing money, even though they're reporting record revenues. So that brings us to cost. A couple of things we wanted to do to make sure that we are as efficient as we can in terms of cost. There's some stuff we just can't change. The fact that AI models are still quite expensive to core and use, we can't really change that. But we can do as much as we can in terms of limiting our usage. And that means only analyzing things that have changed, which turns out to be good for cost control, but also good for user experience. Because initially we didn't do that, and we quickly found that it's actually really annoying to be told that something is wrong and you didn't change that code. Some other dude did. Like, okay, why are you telling me this? This is not something that I even touched. So making that change to only analyze the lines of code that change turns out to be good for user experience. But also, we have to limit how many PRs we scan for free users, people that are not paying us. And lastly, when it comes to like a retry, so again, Lambda, triggered by EventBridge, you get built-in retries, that's great. But what we don't want is when that built-in retry happens, we analyze everything again, and then again spending all of that AWS budget on things that we already analyzed in the past. And also it helps with dealing with timeouts as well if we don't process files that we've already processed in the past. And also, good for developer experience in terms of, okay, if we scan something, we notice a problem, and we add a comment to your PR, and then somewhere along the line, after we analyze your file, GitHub told us, as you know, you've called us too many times, and we had that, and initially, without some kind of control around that, we ended up making multiple duplicated comments on the same pull request, which was also a bad user experience. So what we did was we introduced a very lightweight, durable execution kind of framework for how we're processing the PRs, so that we make sure that on the retry, we don't reprocess things that we've done in the past. So when I say durable execution, I think, well, we basically have got simple checkpoints. If you've done any kind of idempotency control, this should look familiar to you, whereby for every single important step, like calling Bedrock to analyze your code changes or making a comment to the PR, we make sure that we capture that. We've got some kind of unique idempotency token so that we know the next time on a retry, we've done this already, so we can just take the result from the last time and then skip over it. Okay? So you may think, oh, actually someone asked me this, well, that sounds like the kind of thing you may want to do with step functions within AWS. Well, step functions gives you durable executions for your code. So why not just write all of that step in terms of analyzing code changes, making comments to the PR, things like that, turn that into step functions instead. The short answer is that, well, it's a lot of code to turn that into step functions. It's going to be quite difficult, and the checkpoints is just much easier to implement and understand because we are just looking at normal code as opposed to having to split your business logic between ASL, the Amazon State language, and your normal JavaScript or TypeScript or whatever code you have. So when it comes to having a solution that's easy to understand, having checkpoints as a really lightweight durable execution framework is just easier to reason with and implement compared to using step functions. And also much easier testing as well. And then the next lesson is, well, latency is still a bit of a challenge. I talk about the fact that the large PRs can cause our functions to time out, even though we put it on to the maximum 15 minutes. But you can see here that on average, those calls to Bedrock to analyze individual files are taking about 20-25 seconds to respond. And because we are also limiting the number of parallel requests we make for individual PRs for fair usage, so that means for large PRs, it can still take quite a long time. A big part of that is because of the latency from the models. Interestingly, it also means that when it comes to Lambda, where you are billed by the milliseconds of execution time, while you're waiting 45 seconds or whatever for response from a Bedrock, you are being charged for every single millisecond of that, but you're not doing anything with that CPU. So all of that CPU cycle you're paying for is going to waste. If you're talking about EC2 or containers where you're paid by the hour anyway, you probably wouldn't worry about this as much. But when it comes to Lambda and the pay per use and the per millisecond usage pricing, you are going to have to think about, okay, what do we do at scale about all of these wasted CPU cycles that we are paying for and not actually using? So one thing you could do, at least something that I thought about but we didn't end up implementing was, well, there's a lot of static analysis too we can actually run locally as in on the Lambda function while we're waiting for response from Bedrock. So that basically gives us 45 seconds of unhindered CPU cycle we can just use for whatever. So we can see, oh, your project is running CDK, or we can run the CDK nag on your CDK code to identify additional things without having to call machine LLM model to identify, or we can run equivalents for CloudFormation, Serverless framework, Terraform, what have you. So there's a lot of static analysis tools you can actually run while you're waiting for response from Bedrock. So you make use of those CPU cycles as well. And lastly, hallucinations is still a thing. So with Claude, and we basically in our prompt we're saying, please give us back JSON, so we can then take that and create a nice looking comment on the PR. And 99.9% of the time is absolutely fine, as you expect. Occasionally, it just goes, nope. Here's some plain text string. Deal with it. Luckily, when things like this happen, it's quite easy to deal with because we're going to pass that JSON. So when it doesn't pass, we know, okay, this is a problem. It just gets fixed on a retry. But we also see other hallucinations that are more difficult to catch. For example, in that comment, we tell you what the problem is, what's the impact, and some references to like well-known standards, things like OWASP and things like that for security and things like that. Sometimes it just makes up stuff that doesn't exist. Like, this sounds like the thing should be on the OWASP. Let's just add that to OWASP. Of course, this is still quite easy to catch because, well, if it's a code that doesn't exist on the whatever standard it's referencing and it's giving us an invalid URL, we can just make a ping to the URL to know if it's 404, then obviously this is a dud. Let's just remove that particular line from the JSON. Other times, it's even more difficult to catch. We say, hey, here are the lines that have changed, here are the changes, please analyze this. And then goes, okay, yeah, sure, sir. Here's the response, and on line number 18, this is the problem. And we go to GitHub, say, okay, please add a comment to line number 18 with this thing. And GitHub goes, that's no line number 18, you idiot. And we're like, okay, god damn it. So it hallucinates all kind of things. Anything you can possibly hallucinate, it does, including this example I showed you earlier about identifying some unsafe use of this YAML library to parse YAML. And it's really even helpful to even give you a fix. But then the problem was fixed in the library 4 years ago. This is not entirely the model's fault. We didn't tell the model what version the user is using, right? So we can actually fix this one by basically providing more context. For example, using RAG, we can capture the entire code base the user has, and then feed that, we can use feed that through maybe Bedrock's knowledge base, so that the model actually has understanding of the entire code base it's working at, rather than just a snippet of code that you've changed and trying to figure it out, okay, is this a problem or not? I don't know if you're using an old version of JS YAML. So this problem, we can actually do something about this. But the more we do, RAG, agents, what have you, it's going to yield incremental improvements, user experience, but also, as I mentioned earlier, it's going to increase the cost significantly. So again, if you're building for internal enterprise use, or you're building for your own personal project, that's all fine. You're not going to care about that. But if you're actually trying to build a B2C business and you want to be sustainable and you don't have, say, VC money to burn in the meantime, it's very, very, very difficult. Like we were up against CodeRabbit. I don't know if anyone's used them. Actually, really good product. I really like them. They've got so much more budget. They raise so much millions, and they're able to spend things like myself in terms of sponsoring LinkedIn posts and things like that. We just didn't have a chance to compete. Just no hope to compete without lots of VC money to also back up the marketing, but also the cost of using AI. And again, even much bigger companies, players in the space, also have to now beg their customers to pay more money. $20 a month, it's not going to cut it anymore. Now it's $200. Who knows? Next week it's going to be $2,000. Got a year over there. So those are the lessons we've learned. That yes, when you're building AI is kind of the buzzword you want to throw around to get more funding, hopefully any funding. But a lot of the time you find that a lot of it is just software engineering, right? Okay, so there's a lot of building stuff that you normally do anyway, and AI is, yes, it's the important part of it, it's the smart part of your application, but there's still a lot of stuff to do around how you use AI, how you connect the models to everything else you have in your system, and also beware of a context window size. You may think, oh, all right, I can just throw a bunch of data into the prompt and the model can deal with that. Mostly it can't, but depends on which model you're working with. Really look out for that fiction live benchmark. Probably the best benchmark so far around how effective a model is at dealing with large amount of data in the context window. And also, if you're building a B2C business, you're building stuff with AI, understand that it's still quite expensive. It's really, very challenging to build a sustainable business around it. And I suspect none of the companies that are doing that are actually making any money, even though they got a lot of revenue. And also, think about latency, depending on your use case. For us, latency is a huge problem because of the fact that large PRs got so many different files, and the fact that we analyze individual file changes individually, and hallucinations is still a thing. I'm not sure if it's ever going to go away or if it's a core part of the generative model, right? So things that we've learned. If you want to work together, you can go to theburningmile.com, read my blog, but also see the stuff that I do as well. I work with companies of all kinds of different sizes. So you want to talk about the stuff you want to do, come talk to me afterwards as well. Do we have time for questions, or just ask me during the...
Let's do that during the pizza.
Yeah, let's do that over pizza. Cool. Cheers, guys. All right, thank you very much.